Alrighty, superposition. In part of my DC class, I've started into AC concepts. One of the first problems I give is a superposition problem. And what I've got here is 40 volt DC, 30K resistor, 150K resistor, an 80K resistor, and a secondary power supply that is AC 65 volts. And so we want to do the analysis on it, and we want to put the analysis in a good form. Ordinarily with superposition, you break it into two circuits. I believe Spice will do it as one circuit, just two different analysis. We'll get the answer. We'll verify that. So I've taken this circuit and I've made two out of it. So I've got my AC circuit on top where everything's R30 with an A, same resistors, and my DC circuit on the bottom where everything's D, and my battery source. So standard analysis for DC class is .op, gives me the DC analysis. So what I'm going to do is I'm going to go ahead and simulate it. I'm going to run it, and I'm going to get values. And what it tells me is that my voltage, make the window smaller. There we go. My voltage at node 2 is 0, which is I don't know how they numbered the nodes. I didn't label the wires. If you want to label the wires, it would tell you what voltage you had on what node with respect to ground. So from a DC standpoint, I know I've got 40 volts to this wire, so this must be N003. And I've got 25 volts to this wire. So this must be N004. And then this wire is the same as my ground. So I'm really only looking for two DC values, and there they are. So to put results in terms of the voltage drop across the 30K resistor would be the difference between 40 and 25.4. So let's make that 14.6. That would be the drop across the 30K resistor. So the 30K resistor, the DC voltage would be 14.6 volts. Now the 80K and the 150K are both in parallel. It's 25.4 volts from a DC standpoint. So if I go back to the superposition, that's what you see. These two are really in parallel in the DC circuit. My currents, I got my DC current through R80D. It's right there. It is 0.32 milliamps. My current through my 30 ohm resistor or 30K resistor is 0.48 milliamps, and my current through my 150 is about 1.17 milliamps. So I can put those currents in there. In my DC class, I don't really worry about the direction so much. We are using conventional current flow, so whatever is flowing out through the 30K should be equal to what's going through the 80 and the 150. And in fact, they are. The signs are off a little bit. Yep. So it'd be like 17 and 32 would be 49 basically. So 0.49 milliamps through the 30. Go back to that results page. DC current is 0.49 M for milli. And then one was 32. It should be that one, 0.32 milli. And the other one was 0.17 milli. So I've got my DC current and my DC voltage. Just from doing the DC analysis, on my double circuit. What I want to do is I want to do DC analysis on my circuit before I break it up, because I think what will happen is Spice will ignore the AC and I'll get the same values. So I put dot op in here and I'm going to run it. And yes, I did get these same values. I got a 40, a 25. Yep. These values are the same from a DC analysis standpoint as what I got when I broke the circuit up twice. Okay. So 25.4, 40 minus 25.4 is my 14.6. And then my currents are directly 0.32, 0.49, and 0.17 milliamps. So all my currents are the same as what I got on the previous page. So I'm going to close that analysis. I'm going to go back over to this page. And now what we want to do from a superposition standpoint, if you're solving it, is we want to do the AC. So in order to set the AC voltage, I want to show that real quick. I want to go in and set a voltage source. And just a random voltage source, and then to set the value AC, what I did is I right mouse clicked on it, went to advanced, and then I put in the RMS value where it says amplitude. And purists will have a problem with that, but for our sake, our purposes, if we start out with a voltage that we consider RMS, our values that it gives us for current and everything will be in RMS. So it stays apples for apples, if you will. So I'm going to cancel that and cancel that, and then I'm going to get rid of that component. That's how I set the voltages. To set the AC analysis, I'm going to simulate, edit simulation card, and I want to do AC analysis. I'm going to do a list of frequencies. We only want our analysis to be at the one frequency that we're given. This AC analysis allows the analysis to be done through many different frequencies. We're just using one. So that's the easiest way to get to the one frequency. It is 60 hertz. If I don't give a hertz rating, use 60. I think in the problems I assigned, I used 100 and 150. So one analysis would be at 100, the other analysis would be at 150 for that particular problem. So I've got my analysis set. I'm going to do it at one frequency. And what you see is I've got another analysis thing that's following me around till I click it. And then my dot op goes to a semicolon. So now it's just a comment. And the next time I click run, I will get the AC values. And that's what we want. We want the AC values. So now what you see is I've got 65 volts. And I'm going to move this down. 65 volts, which would be across the AC source. And then I've got another voltage source that's about 15.5. So that's going to be 39.5 will be the difference here across this 80K resistor. So 39.5. 15.5. These two are in parallel this way now. So 15.5 for those two, and then 39.5. Go to my analysis, my AC voltage, and let's see, there we go. 30K AC volts would be 15.5. 150 would be 15.5, and the other one would be 39.5, just rounding roughly. Those are volts, so I don't have to do anything as far as the unit goes, because I would assume voltages in volts. Alright, my AC currents are, I can get those directly. The 80K current should split into the 30 and the 150K. So if I go down here to my R80, I've got 0.62, which splits into 0.52 and 0.10. So that's right, 0.62, 0.52, and 0.10 are my currents. So 0.62 milli. And for my 30K, it was most of it, 0.52. And then for my 150K, I got the 0.10 milli. Those are my results for that circuit. Okay, this is broken into double. And in Spice, I'm not sure we have to do the second circuit. I think all we have to do is the second analysis. So I'm going to do that over here. I'm going to edit my simulation command. I'm going to go to AC analysis, just like I did in the other circuit. I want a list. I want it at 60 hertz because I didn't give you a frequency. We'll put that in there. It's going to change to a semicolon, and I'm going to run it. And yes, I get the same. So on AC analysis, it ignores the DC source. On DC analysis, it ignores the AC source. You get the values. You don't necessarily have to break them up, which is easier. And I get my 0.62, my 0.52, and my 0.10. So I get the exact same analysis. If I was to use two AC sources at two different frequencies, I would go with the two circuits. So you got your voltages at your different frequencies in each circuit. Do your analysis. Since we broke it up into two, you could actually do your analysis twice and actually see how it goes. But that should get you through the superposition problem. I obviously didn't give you the one I asked, but I gave you enough similarity that you should be able to basically follow this video and get through it. And I thank you for watching.